Hello, welcome back. If you made it that far watching all these videos, you are already a master on these quadratics. So today we are going to cover a few more exercises. This is again the high level. Mostly when you get these, look at them and see what you can do. Try to solve it, and if you cannot solve it, then watch the video. So I'm going to show you something here. This one is 8x cubed minus 12x squared plus 2x minus 3. But look at this. There is a catch here, okay? And that catch, if you look at 2x minus 3, on the first part also, let's say 2x minus 3. So there are two parts here. Okay? If you look at that part here, you can get a 2x minus 3 there. So let's go ahead and deal with it. So you can rewrite this. You can say 8x cubed minus 12x squared plus 2x minus 3 is equal to 0. So let's factor. If we say 4x squared here, we can get 2x minus 3 here, and then plus we can put 1 to make it clear, times 2x minus 3 is equal to 0. From there it becomes easier. We can say that 2x minus 3 factor 4x squared plus 1 is equal to 0. Okay? To get this one 0, we have to get the two factors. See if they can be null. Okay? Let's see here. We can say 2x minus 3 is equal to 0. That yields x is equal to 3/2. Okay? So that is one solution. And the second part here is 4x squared plus 1 is equal to 0, meaning that 4x squared is equal to -1. But if you look at that, we have seen that we are solving these in R, not in the complex system. So that means this one is not good. So not in R, not in real number system. So what is left is this. So solution finally x is equal to 3/2. So I hope you understand this one, and it was a simple one, but if you don't look at it, you can start doing a lot of funny things and wasting time. So next time you get something like this, watch it and see what you can do before you start. Okay? Thank you. Number 19 is a challenge. You should pause it and try to solve it. We have 3 challenges here. First, look at the denominator here. X minus 4, x minus 3, and what is here we don't know. So we have to see what are the factors here also. So we dive into that and try to find those factors. Okay? And as you know, if I say x squared minus 7x plus 12, I want to factor that. I would say I have to find two numbers that add up to -7, and the product is 12 times 1 here. So product is AC and the sum is minus B. So what are these two numbers? Think of two numbers for me. I thought it was -4, -4, and -3. What do you think? Okay, so we can say that we can get x squared minus 4x minus 3x plus 12. We can say, let's see here, is equal to, you see these two parts now here, so x times x minus 4 minus 3 times x minus 4, correct? So that gives us x minus 3 factor x minus 4. So we can rewrite our original equation here. We can say that it is 3x over x minus 4 is equal to 2x over x minus 3 plus 6 over x minus 3 times x minus 4. Before we go any further, when you see this, there's a condition here. X must not be equal to 4 and x must not be equal to 3. This is the condition to solve this. So if you find any solution involving these two numbers, that will not be a valid solution, because it will make a denominator 0, and if you divide something by 0, it's not good. Okay, so let me solve the rest now. So knowing what we know, now we can just put all these on the same denominator. The common denominator is x minus 3 times x minus 4. To get that here, we have to multiply 3x by x times x minus 3, and this is what I have here. And for the 2x, we have to multiply it by x minus 4, and the 6 will not get anything because it's already the common denominator under 6. So we get that. Okay, and once we do that, we group them. We just make our multiplication and the group, and we get this equation: x squared minus x minus 6 is equal to 0. Find two numbers for factoring that add up to -1, and the product is -6. -3 and 2 are good candidates. So we do x squared minus 3x plus 2x. We just break this one into two pieces. Minus 6 equals to 0, and we factor here x factoring x minus 3 plus 2 factor x minus 3 is equal to 0. Otherwise, x plus 2 times x minus 3 equals 0. But we know that if we take this one, we get x is equal to 3. That's not good. So okay, so we just discard that one, and x plus 2 is equal to 0. That means x is equal to -2. So if we plug in this equation here, we can find that we can verify that 1 is equal to 1 at the end, because you plug in, you get 1 this side, and you get here 30 over 30. So that's just 1. So you can verify it also on your own. Okay, thank you. Here is number 20. Now we have number 20 here, and one of the last parts of this is another situation we have not seen yet. And if we look at this one, we can say that 5x squared minus 21x minus 20. We want to factor this. Here our a is this, our b is -21, our c is minus 20. So we need two numbers. X and y, or a and b, they add up to b, with n1 plus n2 is equal to b, or -21, and n1 times n2 is equal to ac, or -100. Okay, so this is what we need to find. Easy. If you look at this carefully, if you take -25 and 4. What do we get? This is exactly what we need. So now we break the b into these two numbers. So 5x squared minus 21x becomes minus 25x plus 4x. Then minus 20, we can say this is equal to, now we can put 5x in factor here. We will be factoring x minus 5, and here we can put the 4 in factor, x minus 5. Now we have that and we have that, so we can say this is equal to 5x plus 4 times x minus 5, and this is what the question is. So we can say 5x squared minus 21x minus 20. If we factor it, we get 5x plus 4 times x minus 5. I hope you can do this now if you have other equations. Okay, thank you. Okay, we have now reached our last part of these, because we have seen all type of situations. This is exercise number 21, and I expect you now to know most of these situations. And after this one, I hope that you are able to solve any type of these quadratics. All you have to do is to watch what is going on. And in this situation here, we have a right triangle, and we have one of the legs is 68 meters longer than the other, and they give us the semi-perimeter. Half of the perimeter of the triangle is 112 meters. So they are asking us to find the hypotenuse and the two legs, and then to calculate the area. Little of geometry, but we will do it. Okay, look at our typical example here. If we call BC x, so we say BC is equal to x, okay, here, and say AC is the hypotenuse, just HYP, and the other leg is 68 meters longer than x. Okay, so we say AB is equal to BC plus 68 is equal to x plus 68. There we have this. But what do we know in this? We know that the hypotenuse squared, if I call it AC, or let's call it if we look here, we know that from the Pythagorean theorem that hypotenuse squared is the sum of the other two squares, so is equal to x squared plus x plus 68 squared. We know that, right? So we have other information though. They are saying that the semi-perimeter here is 112. That means y plus x plus 68 over 2 is equal to 112. Okay, so all we have to do is to try to pull y from this. We can say that y plus 2x plus 68 is equal to 112 times 2, correct? Or y is equal to 224 minus 68 minus 2x. You subtract 156 minus 2x, correct? We have that. Now if we replace the y by its value here, we get a new equation saying that 168 minus 2x squared is equal to x squared plus x plus 68 squared. and this is what we are going to solve. Okay, let's go and calculate these two parts. For the first part, we can get here in this part here, we can get 156 squared minus 2 times 156 times 2x, so minus 4 times 156 times x plus 2x squared, so 4x squared is equal to x squared plus, here we do the same thing, x squared plus 2 times 68 times x plus 68 squared. That will be very big numbers, but let's group. So we have the 4x squared. Let's take the x squareds first. This one goes, this is 2x squared, correct? We bring them here, minus 2x squared, and then the x is minus 4 times 156 x and minus 2 times 68 x plus 156 squared minus 68 squared is equal to 0. Okay, so now we have the common terms. 4x squared minus 2x squared is 2x squared minus, now we need the calculator here, correct? You say 156 times 4 equals 624x minus, we can bring back our calculator, 68 times 2 is 136 x plus 156 squared 56 squared equals 24336 minus 68 squared, 68 times 68 equals 4624. Okay, 4624 is equal to 0. Here is 2x squared minus 760x plus 24336. Let's bring this side here. 24336 minus 4624 equals 19712 is equal to 0. Okay, let's divide by 2. We get x squared minus 760 divided by 2 is 380x plus, we can get here is 9856 is equal to 0. Let me try to verify that instead of doing it mentally here. Answer divided by 2 9856. Okay, so we have to solve this one, and I'm going to, if we calculate delta here, we get these numbers. They are big. You can practice to use your calculator to find that the square root of delta is equal to 324, and then the first x value is 352, and the second one is 28. Now let's argue on something. If we have a perimeter, a semi-perimeter of 112 or a perimeter of 224, and somebody pops up and say one of the legs is 352, the smaller length, that's something is not working. So this is not good. So we have to reject that one and take the 28. Okay, so once we have the 28, now we can find that the hypotenuse is very simple. Right now we have two ways to find it, but we will use the simplest of the ways. We have the semi-perimeter, and we know x is equal to 28, meaning that x plus 68 is equal to 28 plus 68 is equal to 96 meters. Now if we take half of these two, the two legs, if we add the two legs, we have the perimeter that is equal to 224. Now the other minus the two legs, first leg is 28, the second leg is 96. That difference is, like you can see here, we have 124. 224 minus 124 is 100. Let's do this way. I would say hypotenuse here, not the perimeter. It's 224, the perimeter, minus the two sides. That is equal to 100. That's all we needed. Now there is one question regarding area. Is the base times the height over 2 is equal to 28 times 96 over 2 is equal to, let's bring up our calculator. You can say let's clear this. 28 times 96 equals, divided by 2 equals 1344. Okay, so 1344 square meters. I hope you understood. So all the problems will be similar. So this marks the end of our quadratics. If you have further questions, you can always ask me below the videos. If you see mistakes, we can correct them. Okay, thank you, and see you next time in another topic. This one was long.